Okay, class, this is a video over lesson 25, proving triangles congruent. So just a little bit of review. If you haven't watched the videos from last week over lesson 24, go back and watch those and make sure to complete those lesson worksheets. But that lesson talked about how to prove triangles congruent based upon the side postulate and then side angle side, where the angle has to be in between the two sides. So today, the next two postulates we're going to use to prove triangles congruent is angle, side angle. So if you have a side here, and then you know this angle and this angle, and then angle, angle, side. So meaning you have an angle, angle, or you could even say this angle, and then you know how long this side is. Okay, so pretty much he shows in the videos, and we'll watch these next week. Go ahead and watch them if you want to, just to get some extra explanation. But in the Matthew C. official videos, he pretty much lines up a bar and says if you have these two angles and used your compass and protractor, or your protractor, and you drew it out, let's say you were told this one was 40 and this one was 65. And you drew out a 40-degree angle, you drew out a 65-degree angle, and you already were given this side right here, then you would automatically know what this angle is. It's not going to change because of these being given. This is automatically going to be the same every time. So that's angle, side, angle. Angle, side, angle. So given two angles, the side in between, you can know what the third angle is, and therefore all the parts of the triangle are going to be congruent. The other one is similar, and it's called angle, angle, side. So that's saying if you were given an angle here of 40 degrees, an angle here of 65, and then told that this side is 8, you'd be able to figure out this angle. So these two postulates right here are based upon the same thing. In a triangle, if you're given two angles, you can know the third one. Because remember, the sum of the interior angles of a triangle. So this is where it's important to know your theorems from lesson 22. So make sure that you have committed those to memorization. So your interior angles of your triangle are going to equal 180. So if you know what two of the angles are, you just have to add those together, subtract that sum, so the 40 and 65, subtract that from 180, and you would know what your third angle is, which is 75. So that's the reason that that's going to make the triangles, you can prove it congruent, because if you can prove that two of the angles are the same, then you can prove that the third angle is the same. And that goes on to our next point, which is if you know that the angles are the same, the angles correspond to the sides that are across from each one. So if you can prove that this angle, let me draw a new picture. So if you have two triangles, and you know that each of these angles are the same, you know that this angle is the same, and because of that, you know that this angle is, and therefore the sides across from the angles are going to have the same measurement. So I'm just kind of making up some numbers here, and we'll say this one's 3. So when you can prove that a triangle is congruent because of angle, angle, side, angle, pretty much if two of the angles are the same, then you know enough to know that a triangle is made up of 3 angles, 3 sides. If those are all congruent, then all 6 corresponding components, or all 6 corresponding parts, are also congruent. So pretty much once you have taken one of these postulates, side, angle, angle, side, angle, so the 4 that we're going to be practicing over and over from 24 and 25, and you've proven that the triangles are congruent, then you can say all the corresponding parts of the two triangles are congruent. So this is congruent to this is congruent to this, this is congruent to this side because it's a corresponding part. So that's why lesson 23, making sure your corresponding parts and how those line up and understanding that. So that part is called, that whole idea is called corresponding parts of congruent triangles are congruent. So it's a big old acronym. And you can use that in your proof so that you don't have to write out this huge long sentence. So once you learn that two triangles are congruent, then you can say that all 6 corresponding components are also congruent. And this is because corresponding parts of congruent triangles are congruent. So corresponding parts of congruent triangles are congruent. Okay, so that's going to be important, and it's going to walk us through that on 25A and seeing that concept a little bit more, and then we'll have it more in our homework. The other thing that is going to be a good reason that we can use, and the reason you're going to need that is sometimes in our problems, it's not going to ask us to prove that triangles are congruent. We'll have to do that. That'll be a step to maybe get to our last thing, proving that another side's congruent. And not that we're given enough information like we have been to prove that a side's congruent based off our givens, but because of everything else, we can prove a triangle's congruent, and then because of the corresponding parts of congruent triangles are congruent, we could say that those parts are congruent. So you'll see this played out more, but it's just another piece of the puzzle in what we've been learning. Okay, so the fourth concept that is introduced in lesson 25 is called the amplified parallelogram theorem. These are really fancy names. Okay, so APT. And this pretty much states things you already know. It just gives it a fancy name, so you can use that. So throughout our lessons, we have been assuming that the opposite sides of a parallelogram, so if you have a parallelogram, so we've been assuming that the opposite sides are congruent. So this side's congruent to this side is congruent to this side. So we're going to do a formal proof in a second showing that. But when you need to write that, you can state that you can write the opposite sides of a rectangle are congruent, or opposite sides of a parallelogram are congruent. Or you could simply write APT. And we're going to see this in our homework too. So if we need to write the reason, we can just write APT, stating that the opposite sides of a parallelogram are congruent. You can write that out, or you can just write APT. Okay, so I'm going to pause this and make another video going over our example problem from our homework.